In this section, we're also going to look at equations of lines that we can graph. And an equation of a line can be written as long as you know two pieces of information. Just like if we draw a line, all we need to know are 2 points on the line. Okay, the few things that we could use as criteria, we could use the slope of the line, which is how slanted the line is, and the y-intercept, which is where the line crosses the y-axis. If you have the slope and just another point, other than the y-intercept, you could also write the equation of a line, or if you know 2 points, you could write the equation of the line. And the reason we can do that is because we can find the slope of a line first using the slope formula. So the slope of a line is given by the difference in the y's, or often called the rise, so y2 minus y1, and then divided by the difference in the x's, often called the run, x2 minus x1. So here are a few forms of lines. The first one is probably the most familiar, which is slope-intercept form, y equals mx plus b. And so the slope goes in the first spot, the coefficient of x, and the y-intercept is b. The next is point-slope form, which is just a modified form of the slope formula. And it's y minus y1 is equal to m times the quantity x minus x1, where x1 comma y1 is any point on the given line. A standard form is another helpful way to write the equation of a line in that it's easy to tell the intercepts pretty quickly. It looks like this: ax plus by equals c. Horizontal and vertical lines, they're pretty special, and a horizontal line is always of the form y equals some constant, c, and a vertical line is always x equals some constant. And we also have some relationships between two lines, and that two lines that are in the same plane that never intersect are called parallel lines, and they actually have the same slope because they are slanted at the same angle. Perpendicular lines, on the other hand, intersect at right angles, and they have slopes that are opposite reciprocals. So an example of this would be if one slope of the first line is 2 and a slope of a second line is negative 1/2. You see the difference between them. They're opposite signs. One's positive and one's negative, and then they're reciprocals of one another. Let's take a look at some examples. We want to write an equation of the following line using slope-intercept form. Okay, the first thing that I want to be able to do is to tell if the y-intercept is clear. Okay, so if the y-intercept is clear, I'm going to mark it, and it looks like it's at -2, so b is -2. The next thing is to determine what the slope of the line is. So find another point that has integer coordinates. So I'm going to choose this next one that's at 3, -1. Now we can either use the slope formula with these 2 points, or just count how to get from one point to the next, which is the rise over the run. So we would count up 1 and right 3, and therefore the slope is 1/3. Okay, but just another way, if you are unable to tell from the graph, just to use the slope formula. So it's -1 minus -2, that's the change in the y's, over 3 minus 0, and we also get 1/3. Notice the slope is positive and the line is rising or going up from left to right, and that should be the case. Lastly, because we have the slope and the y-intercept, we're going to use slope-intercept form. Y equals mx plus b, and therefore y equals 1/3 x plus -2 or -2. Okay, so we also want to write an equation of a line that's parallel to the given lines in number 1 and perpendicular to that line that passes through the point 3, 1. Okay, so you recall the equation of the line was y equals 1/3 x minus 2. So we write this slope down, and I'll call it m1. m1 is 1/3. And in part A, to write the equation of the parallel line, our slope of m2, the second line, is also going to be 1/3. But we have this point located at 3, 1 that we have to take into account. So at this point, I'm going to use point slope form, which is y minus y1 equals m times x minus x1, and just substitute these three values in the appropriate place. So y minus 1, y1, is equal to m, 1/3, times the quantity x minus 3. And this is a valid equation of the line. Typically, we want to write the final equation in slope-intercept form, so I'm going to do that. And the way that we can transform this equation is to first distribute the 1/3. So we're left with y minus 1 equals 1/3 x minus 1/3 times 3 is 1. And then lastly, add 1 to both sides. And we get y equals 1/3 x and then plus 0, so I'm not going to write it at all. That means the y-intercept of this new line is at 0, or this line passes through the origin. Okay, but we also want to find the equation of a line that's perpendicular. And so recall that m1 is 1/3, that was the slope of the given line. So this time m2, the slope of my new line, is not the same. It's going to be the opposite reciprocal, so -3/1, or just -3. And we'll use point slope form again. So y minus y1 equals m times x minus x1. Substitute the same point, because this is also going to pass through the point 3, 1. So y minus 1 equals -3 times the quantity x minus 3. And then simplify. And we get y minus 1 equals -3x plus 9, and then add 1 to both sides. So our final equation is y equals -3x plus 10.